All right. Okay, good. All right. So to solve problems involving bearing. All right. So your first example.
Yeah.
All right. This is your first example. You don't need to draw the ship now, all right? You just copy down the sentence there. A ship sails southwest for 80 kilometers from port A, then to the east for another 100 kilometers. How far is the ship from port A? Question A. Question B. Find the bearing of the ship from port A. This is all you are given. No diagram. So what you're going to do first for me in this beginning of our lesson, draw out how does your sentence, your statement will be represented in a diagram. That's your first task. Okay, because it's very simple, it's very short. Southwest for 80 kilometers from port A. You look at that. I stress on the word from. So if you recall, all right, from port A, it means you are at port A. So your north line will be at port A. All right, Kwansin, I just showed you the first slide, yeah, for today, the first example. Okay, then after that, we move east, for another 100 kilometers. So please sketch it out for me. If you do not need to solve it yet, if you do not know, all right, you just hold on. Just I want to see now because your diagram is important. If you drew wrongly, definitely it will affect your part A and part B question. Okay, so hold on. I give you time, at least another minute just to draw out, all right? So this time there's additional information you can see is your distance. The last lesson we do not have distance. We just talk. It's all about angle. So this one, this is why it's called problem solving. Okay. All right. I'm not going to ask you to show me, okay, because this is just your first example. So we hold on. All right. So let's have a look whether you have drawn. All right, same as mine. Must be the same, okay? Because your direction is fixed. So a ship sails southwest for 80 kilometers from port A. So you must know your direction, yeah? Your southwest. Okay, that is what we have done the beginning of your bearing chapter, okay? So southwest, right? So you just put your point A anywhere. Then let's move to your southwest. So we'll name it as point B. So southwest should be there. Okay. Oh, too fast already. All right. Look. So southwest is in the third quadrant. All right. Remember? So third quadrant. So we move this way. Then I say it's from port A. So you have your north line at port A. All right. So you move 80 kilometers. All right. So now the next sentence it says then to the east for another 100 kilometers. So east is exactly to your right hand side. All right, it's straight right hand side. It's no slanting to anywhere. So straight right hand side. Okay, so we can put it as point C, then 100 kilometer. Now we put in the angle what we know. Okay, remember this is your north line. Okay, so it's a vertical straight line touching a horizontal. This is a horizontal straight line. Why? Because it's east. It's not slanted, so it's definitely 90 degree. That's the key word here. Okay, so 90 degree. So you can say this is your isosceles triangle. All right, so 45, 45. Okay, so this is all the information we can get from the statement here. A lot, yeah, you can get it from a statement. All right, when you draw there's more. Okay, so now let's answer the question, how far is the ship from port A? So your port A is here, your ship is now at here, yeah? C. So basically you are finding what is AC, okay? The line of AC, you're finding here, all right? So let's have a look. How can I get it? So it's a step-by-step process. So you see, why in the world am I finding sine 45? Okay. So sine 45, I'm finding this line here, BD. I want to know how much is BD. Why I want to find BD? Because this is the only angle, all right? It is in a right angle triangle. So this is the only angle that I know, and it is in a right angle triangle. So I just want to refresh your memory. So in a right angle triangle, the concept that you can apply will be, here you can see your trigonometry, all right? Or what's the other one? What is the other concept that you can apply in a right angle triangle? I give you one already. What's the other one? Anybody? In a right angle triangle, there's two concepts. Pythagoras theorem. Okay, yes. Okay, so it's either you are going to apply your Pythagoras theorem or your trigonometry. So in this case, it's trigonometry because you can't use Pythagoras theorem. Also, why? Because you only know one length, which is AD. You do not know what's AD. All right. If you know what's AD, then you can use Pythagoras theorem rather than trigonometry. All right. So you see, we are applying all your previous concept here. Okay. So I'm using, like I said, I'm using trigo, and the best one is sinus, all right, to find BD. Okay, then you substitute your value, you will get 56.57 kilometer. So BD is 56.57 kilometer. Okay, I hope you are listening and also jotting down. Jashan, next time be on time, please. You're already way too late, 20 minutes late for my class. Okay, so we got BD. So, like I said, this is an isosceles triangle. So AD is also 56.57. Why is it isosceles triangle? Look at this. This is 90 and this is 45, 45. So the angle is equal. So it is an isosceles triangle. Just for those who are like a bit blur blur in the morning, not sure why. All right. Okay, so now I know BD is 56.57 and also AD. So remember, our mission is to find AC, all right? The distance from port A to your ship. Your ship is currently at point C. Okay, so now, what else can we do? All right, we can find out how much is DC. Because I gave you BC is 100 kilometer. BD you have found out already is 56.57. So BC will be 43.43. Okay, all right. So AD you also already know. Okay, you know it's 56.57. DC you already gotten, which is 43.43. So therefore, to find your AC, all right, your part A question, you use your Pythagoras theorem. All right, Pythagoras theorem. Hello, Nigel. You're late. Oh, all right. I am already ending my explanation of example A. Okay, so Pythagoras theorem, quickly calculate for me. So what is the distance of the ship and your port A? May I have someone else beside Eileen? No offense, yeah, Eileen, I know you are here, but I want to see also the other people. Make sure they are here in my class before I pick names. Okay. So what's the distance of your ship and from port A? Calculate for me. Copy down nicely your diagram, inform your working steps, and calculate what's AC. Okay, just another minute. Anybody? Oh, not yet, not yet. Got another 30 more seconds. Hold on. My dear Marcus, I hope you can catch up, all right, because you missed the first part. I don't know whether you know God say, but this is nothing got to do with the bearing yet, all right? So this is just applying your previous concept, so you might be able also to answer my questions here. Okay, anybody with the answer? What is the distance of the ship from port A? Working style I've shown you is just you need to calculate for me. All right, nobody, nobody. I'm gonna pick names. Yes, Kevin. Let's see what you write. 71.29 kilometer. Oh, okay, you got 29. All right, let's see. Maybe you round off. Okay, look this. You should get AD squared is 56.57 squared and 43.43 squared. So you press yes. You should get 71.32 kilometer. Kevin, please check again. Because from this data, you should get 71.32. Because if you are following what I gave you is 56.57 and 43.43, all of you should get 71.32. Another thing is, please, all right, remember for trigo or any other is usually the decimal is 2 decimal places or 4 significant figures. Please don't round off to whole number or even make it as one decimal place, or in other words 3 significant figures. No, yeah, okay. The correct one should be 2 decimal places. Okay, Kevin, have you checked what happened? Why do you only get 0.29? Okay, good. All right, so it should be 71.32. Thank you, Jin Jen. Okay, all right, so this is your SPM question here, yeah? All right, so if you're not lucky, it won't be that easy. You have to draw out your diagram, okay? Then you have to think a little bit, okay? But usually it's only one question, but you see this one is a 2-part question. So now let's look at part B question. Okay, part B question is now to find the bearing of the ship from port A. All right, so the same diagram, you just add, okay, this is for those who are absent from my class, previous class. So how to find bearing? There's 2 concepts you have to remember. It is from where you are, and from that point, you have to draw your north line. And once you got your north line at that point, you move clockwise direction. So for this question, I repeat, your ship is now at point C. It says here from the question, from point A. So from the beginning, you already drawn your very nice north line from A. So now let's find the bearing, which I already drawn nicely for you. So you move clockwise direction from the north line at A until you reach the line touching your AC. All right, it must be a line, yeah, connecting line. So that will be your bearing. Okay, so now you have to think a little bit. All right, so we have 45 here, we have 45. We got the 2 distance, AD and DC. Hey, we can find the value or the angle of X. All right, again, this is a right angle triangle, because if this is a right angle triangle, here should be also 90. So this is a right angle triangle. All right, so therefore, what concept can we use to find your X? Anybody? We are finding the angle of X first, yeah? Then only we can find your bearing here, your theta. So what's the concept can we use? Okay, let me pick a person. Ini macam Okay, the next person I see, boom, in my screen here will be. Okay, I change a bit. All right, okay. Joshua already saved you all right? He says here is tangent. Tangent x, all right? Yes, all right, you can use tangent. Okay, now, can you use other trigonometry besides tangent? Is it only tangent? Okay, Kevin, what do you say? Sine, all right. And you can use all the three. You can use tangent, you can use sinus, you can use cosine. Why? Remember, because we already found out what is AC also from part A. We already know what is AC, okay? But the tip here, right? This is tip. Try not to use the value which is part of the question, which is the question of AC now you're finding. Why? You see, let's say you made careless mistake, like just now, Kevin accidentally put 71.29. And then for part B, you're going to use sinus. Sinus X is opposite, that means 43.43 over 71.29. Habis. Gone case already. All right, your value will be different. All right, so the tip here, you use the one from the diagram. So because how do we get 56.37? We use the angle not given, we found from the diagram. Yeah, it's not directly there. All right, you should know it's 45 degree. So we use that. So 56.57 is a solid distance, and 43.43 is also solid because we took 100 minus 56.57. Okay, so to be safe, all right, you use tangent. But you ask me, right? Yes, you can use sinus, and also the other one is cosine. No issues, no problem. But to be safe, you use the one, the value which is already fixed, given to you. Okay, whichever trigger you use, you should get the same value of x here. Okay, so tangent x. All right, you are correct. So let's substitute the value, and you will get 31 minutes or 37.5 degree. All right, so again, look at the option of answers. You have degree and minutes as your option of answer. You can remain here as your degree and minutes, or you can still use 37.5 degree. Then later on, your bearing only you convert into degree and minutes. Because since all you can use calculator, right? No big deal. You just press that one button, they'll convert for you. Okay, so I'm the one who prefer to use degree only. All right, so we know here is 37.5. So how to find your theta? This is the concept, one of the concept that we can use. All right, I told you last week, the last class, you can use your semicircle, you can use your, what is that, 360 full circle, alternate angle, your sum of interior angle, the U shape. Okay, so for this question, we are using your semicircle concept, the 180. All right, so all of you should get 142.5 degree. Okay, we just remain as degree. Okay, all right. So this is called problem solving, a little bit more steps, all right, in the working steps. Okay, so if we are done, let's move on to your second example. All right. Can I move on to your second example? Anybody please say yes, so I can move on.
Yes, teacher.
Yes. Okay. All right, second one. So again, there's no diagram. All right, it's just statement here, situation. Lily moves from point P to Q, which is at the bearing of 230 from P. Then she continues her journey to R, which is at bearing of 345 degrees from Q. Given the angle of PRQ is 65 degrees, find the bearing of P from R. So what I want you to do, I'm going to give you 2 minutes to sketch out your diagram. Okay, you copy and you sketch, so 2 minutes. If you have done within the 2 minutes, before 2 minutes, you can try to solve this. Find the bearing of P from R. Okay, 1 minute, ready? Sketch now, yeah? You are supposed to start to sketch your diagram right now. Okay, okay. All right. So I'm going to review the diagram. So please check with yours. All right. First sentence. Lily moves from from P to Q, which is at the bearing of 230 from P. All right. So you know you have at P, okay, and 230 is in your which quadrant? The third one, isn't it? Okay. The third quadrant, so you should know. All right, third quadrant. So let's move. So my P is there, my Q, see, third quadrant. All right, so this is 230. Okay, can you see the slide? Right. Second sentence. So from Q, she continues her journey to R, which is at a bearing of 345. So now you at from Q, yeah? You are at Q. All right, you can draw your quadrant, or in other words, your north line. All right, quadrant, the fourth quadrant. And where is 345? It is in the fourth quadrant. So that's why your R is there. Okay, so 345. All right, so now we continue. We connect all the 3 points. All right, so connect your P and R. And I even told you that the angle of PRQ there is 65. All right, so this is your diagram. It should look like this. Okay, so now we are going to find the bearing of P from R. So you are going to draw your north line. Okay, so we know that the north line is straight here because based from the first statement, all right, your north line will be here. It's not this way or whatever other way. I repeat, your north line can move, yeah? It's like a compass. It's a compass. It can move. Here also can be your north line, okay? All right, so for R, the north line is also nicely vertically there, vertically upwards, all right? So let's find out, drawing a diagram, where is your bearing of P from R? Okay, it should be there. Okay, before that, this is your alternate angle. Okay, your X here, you can find your alternate angle. So that is your bearing, the theta there, your bearing of P from R. Remember, from north line, move from north line at R, move clockwise direction. Okay, from north line at R, you move clockwise direction until you reach the line of PR. Okay, so I already said this is your, you can use your alternate angle value. So how much is X? Can anyone tell me what's the value of X here? You find here, you're not there, right? This X here. How much? Anybody? Who's this? Asia, how much is it? What's the value of x? Look at my cursor. We're finding this. 15. Okay, thank you, Laila. 15. All right. So 360 minus 345, you get that. So if this is 15, you use the alternate angle concept. Here is also 15. All right. So now, how to find the bearing? Open your eyes. Look. Oh, we found this 15. We found it is 65. So how do we get your theta here or the bearing of P from R? Anyone? What concept can we use? The same person. Okay, again, Laila, thank you very much. So yes, you use the semicircle concept. 180 minus 15 minus 65. Good. Okay, ayo. All right, so is the answer is 100. Okay, so the bearing of P from R is 100 degree. All right, so you have to open and see what other concepts you can use. This is what I got. I use this alternate angle. Mana tahu you want to find here ke, but this one, you find here, right? You use the point P, it's a bit difficult because you won't know how much is here, the one at Q, this part. So the option is finding this one here, your X. Okay, then alternate angle, then you use the 180, your semicircle. Okay. All right, so two versions. One last example. Okay, my last example. Can I move on now to the next slide? Okay. All right, this is your last example. I took it from your textbook because I want you to have a look. The way they give you your statement, yeah, your information is different than the other two previous example. Okay, it's from your textbook, checkpoint 8.1, number 6. So the diagram shows 3 points, P, Q, and R on a horizontal plane. So horizontal plane is just mean a flat surface. Okay, so this is 3D. So basically, you're like looking on top of it. So don't like confuse it. Teacher, how in the world it looks like on a horizontal plane? All right, horizontal. All right, it's flat. So like if I turn this way, you can see your 3 points here. Okay, that is what it means. All right, so you know it is on the flat surface. The 3 point is all on the flat surface. Okay. Next sentence. Given that point P is due north of Q. This is what I want to stress here. It's different than the other two examples, yeah? So I repeat, given that point P is due north of Q, find the bearing of R from Q, R from P, Q from R, and the last one is P from R. Okay, copy this first, then I'll show you, all right? What does the sentence mean? This one, P is due north of Q. Okay, 1 minute. Okay. Finish copying? Everyone finish copying? Done? Okay, all right, all right. Okay, now, so you have to understand, it says P, all right, look at my cursor, P is due north of Q. So meaning your Q here, all right, so from Q, the north line should be here. So if the north line is here, so therefore the P is north of Q, all right? This is what it means now. Look at the slide. Okay, so the north line is pointing there, pointing to P because the statement says P is due north of Q. All right, so I just draw the 4 quadrants so you can really understand. So that's why I say sometimes the north is not like vertically, all right? It can be any other direction, all right? But that one is still staying is north, all right? So this is one of the example here, okay? So bear in mind the north is this way. So everyone else will point R also the north will be this way. Yeah? Cannot be point because remember they are all on the horizontal plane. So takkan point P, the north is left, then suddenly R, boom, is this way. Oh, that means you're going to be wrong already. Okay? All right. So got it? Yeah, your north is there. So let's look at question A. Find the bearing of R from Q. So you have already your north line already at Q. Remember, from will be drawing your north line. So already we have drawn the north line from Q. So what's the bearing of R? Okay. So anyone? What's the answer? What's the bearing of R from Q? Look then, nicely drawn. Yeah, Alim say 048. Okay, can someone second also approve his answer? All right, yes. Okay, so see, good. He remembered. All right, bearing is 3 digits. All right, so your answer is this one. Yeah, look at this. North line. So from the north line, we move by clockwise direction until you reach the line touching of Q and R. Boom, it's there, right? 48. Okay, but in bearing, it must be 3 digits. So no working step, it's just there. Okay, next question. The bearing of R from P. Okay, try. This is like your previous question, yeah, but it's the way they ask you a little bit different only, okay? So this one you all should know how to get the answer. So bearing of R from P. Okay, now I want to pick a person. All right, hold on, don't give the answer. Pick a person. Let's see, let's see. Sean? Sean, can you give me the answer? You get 076. All right, let's check it out. Okay, so basically is this one here, your bearing R from P is this theta. So he says it's 76. Nah, not correct. All right, it's not here. It's not in here, yeah? The bearing is there. So it's the one outside of the triangle. Okay?
Teacher,
Yes.
can you go to the question slide just now for a bit?
Basically the question is the same.
Okay then, thank you, teacher.
All right. Okay, so Sean, you are incorrect. It's not in here, it's outside of the triangle. All right, so how to find, this is your concept, yeah, of your outer, or what you call that, exterior angle, okay? So you can straight away add 48 and 56, all right? So you get 104, okay? Or you can do the long way, this is the fastest way, or the long way. Okay, so 180, 180, finding here, minus 48, minus 56, which you get 76 over here. And then after that, you minus again 180. That's where you get 104. That one is long version. If you're alert, oh, the one outside, we can just add this interior, the opposite interior, 48 and 56. Okay. Right, so that's B. So am I, Sean? Okay, now at least you know your careless mistake. So please draw out the bearing first. Don't straight away, boom. Okay, draw out right there. Okay, now question C, bearing C, bearing C, bearing Q from R. Okay, So you have to draw the north line from R. So I repeat, it should be exactly like the one at P and Q. All right. That's why, like the other day, I told you, your ruler plays an important role. Okay. So you put your ruler on your PQ, it says like this, then you just drag and it should look like this. Because you move a little bit, all right, it will affect your answer. Okay. So just use your ruler, put it nicely. Right, you get your north line from R. Okay, let's find out where's the bearing of Q from R. So from R, we move clockwise. Look at the line clockwise at my cursor until you reach the line of Q and R. So again, from the north line at R, you move clockwise until you reach. So it's again the one outside here. The theta is outside. Okay, now 1 minute to think how in the world to solve this. Okay, so anyone with the answer, please share. Anyone? Let's see. Nobody. I can tell you, you use your zigzag concept. That's the first thing you should know. Zigzag. Okay, so I already give you tips. Zigzag. All right, so should be here is 48. All right, because here's 48, we can use zigzag, because straight line, straight line, straight line. Oh, okay, so this is 48. Now look at this. Hey, isn't it a semicircle? All right, so the bearing of Q from R, it should be 180 plus 48, you will get 228 degree. Okay, all right. It's okay for those who are still not sure. All right, you need to do a lot of practices. Every time maths, you need to do plenty of practices to be very good. Okay, last question from this diagram, bearing of P from R. All right, so we have drawn already your north line from R. So let's find out where's the bearing. So draw out your theta. All right, so draw from R again, but this time it is until P. So you move from north line, all right, move clockwise, clockwise, turn, until you reach your PR, all right? So the one here, that is your theta should be. Okay, so I can tell you, you should know how to get the answer here because now I'm telling you the whole thing there, all right? So please add up and tell me what's the answer. Can I have Asia? I've been calling your name just now. Are you still here? Ding ding ding, Asia. Yes, Asia. Can you tell us what's the bearing? All right, or P from R? Okay, good. Let's see. 270 minus 48. Ayo, Asia, is the whole thing here, you know? Ni tau, this whole thing. All right, so it's already more. 40. Okay, 9. 2, 8. 2, 7. Oh, salah lah, Laila, you're asking. Salah, okay, Laila, no. You take 270 minus 48, you are not getting the theta. You're doing something else. Okay. So for Asia, let's see what is your answer. All right. So it's 284, correct. Okay, so look at how they get to A4. Is basically you add up the whole thing, 180, the 48, and 56, or just 228 plus 56. Okay, so Laila cannot, yeah, it's 270 minus 48 is a different angle. It's not here anymore. The theta is this whole thing, you know. Okay, all right, so that's it. This is our last slide. All right, so you can see here there's a few versions of problem solving that we can ask you all. Okay, so definitely now the next step is to do practices, like I said.